If you haven't already, I would definitely watch the video guide that goes over review one. Review one is a little longer and more extensive. This one starts us out with the same. We're going to simplify these radicals using just our knowledge of the squares and the cubes and the fourths and the fifths. So when you see 8 to the 2/3, you're almost always going to do the root part first. So do 8 to the 1/3, which is the cube root of 8, which is 2, and then 2 squared is 4. Same thing over here. We're going to do the root part first, the 5. So the 1/5 power of negative 32 is just negative 2, and then do the 4, and then negative 2 to the 4th is 16. Same thing here, except the stupid negative, that negative in the exponent in the power is going to move it into the denominator, but everything else is the same. I'm still going to do the 4th root first, or excuse me, the cube root first. The cube root of 64 is 4, and then 4 to the 4th is 256. Then it's 1 over 256. Same thing here. The negative is going to move it down. Then I'm going to do the cube root first. The cube root of 125 is 5, and then 5 squared is 25, so it's 1 over 25. If you have a power to a power, you're going to add 1/2 plus 1/5 is 7/10. Now, excuse me, I said power to power, but this is x to the 1/2 times x to the 1/5. You're counting how many x's, and that's why in this case, you are adding the powers. Here is where you have a power to a power. Then you are multiplying those things, and so 1/3 times 7/2 is indeed 7/6. Again, stress the difference between 5 and 6. 5 is the addition of exponents because you're counting how many x's you have, and here you are multiplying those power to a power, okay? Because you have 3.5 thirds, which is the definition of multiplying. 7 is the more complicated version of 5 because you have to make this look right first. So this is like x to the 2/3 times x to the 10/3. 2/3 and 10/3 is 12/3. 12/3 is just 4. Or you can just combine them like we did on the key. The cube root times another cube root, you can just multiply. And so you get x squared times x to the 10th, which is x to the 12th. And then the cube root of the 12th is 4. Either one of those explanations is fine. Here we're simplifying. 54 is not a perfect cube, but it's made up of negative 27 times 2. So the cube root of 27 is negative 3. And then we can take out 3 of the x's, 6 of the y's, and 21 of the z's. So the cube root of x cubed is x. The cube root of y to the 6 is y squared. The cube root of 21 z's is 7 z's. And then we had to leave behind all the things that didn't work out perfect. 9, we're just taking square roots, so break up 50 into the squares, 25 and 2, and then we can take out 2 of the x's and all 4 y's, leaving behind the 2 and 1 of the x's. 10, if we're going to add and subtract things, they got to be perfect, meaning they got to be an absolute match. And so let's take the 4th root of 81, the 4th root is 16, and we get 3 4th roots of 2's minus 2 4th roots of 2's, which is just 1 4th roots of 2's, which is why we get this. Over here, so this is 7 to the 1/3. So this is stupid. We're just missing 2/3. So we got to multiply by top and bottom by 7 to the 2/3, which is the cube root of 49. So you're just going to throw up that, and then on the bottom, when you have 7 to the 1/3 times 7 to the 2/3, well, you got 7 to the 3/3, which is just 7. Same thing here. The 5 is just going to chill, but you're missing. This is 2 to the 1/4. So you got to multiply top and bottom by 2 to the 3/4. Well, that's what this is, 2 to the 3/4, top and bottom, and then you can simplify. And you do end up getting 5 over 10, which is just 2/5. But that 5 is just going to chill. It doesn't actually play nice with anything. As you can see, it stays there. 11 and 12 are my least favorite, so you have to be really careful how you do those, but you're just completing it. If it's a 1/3, it needs 2/3. This is a 1/4, so it needs 3/4 to complete it. And so that's what we're multiplying top and bottom by. Here we got this same thing, cube root graphs and square root graphs. This is the cube root, so it's going to be negative, so it's going to flip. You can see the s is in the wrong direction. It's going to be a little steeper because of the 2. It's going to be left 3, and it's going to be down 5. So go left 3, down 5, and put your dot, and then instead of s-ing the normal way, it's going to s the other way. Instead of going over 1, down 1, it's going to go over 1, down 2, because it's going to be a little steeper. That 2 affects the slope. So this guy over here is just our normal square root. It's just going to be right 4 and up 2. So just go right 4, up 2, and then draw it. And again, normally square roots go over 1, up 1, and so on. And then solving equations, right? We're going to get it all by itself, so move over that, and then we're going to take everything to the fourth power. And again, if it's an even root, fourth root, square root, you have to check your answers because you can't have negatives under there. And if you look at 16, 16 is not going to work. 5 minus the fourth root of 16, fourth root of 16 is 2. 5 minus 2 is not 7. So you always have to check answers on those. On this one, we're going to move over the 16, then divide by 2, and then at the end, take the cube root of everything. And then we do have to simplify the cube root of 32. 32 is not a perfect cube, but it is 8 and 4. Cube root of 8 is 2, and then we're good. You will have to simplify all the way down to here. Here we're going to square both sides of the equation and get 2, and then we're going to check our answer to make sure it works, and it does. Here we're going to divide by 3 first, and then we're going to take both sides to the 3/4 power. Remember, it's always the reciprocal. If this is 4/3, we're going to raise both sides to the 3/4. And if we're doing 81 to the 3/4, we always do the root first. 81 to the fourth root is 3. 3 cubed is 27. And we do get plus or minus. Remember, plus or minus, because anytime we do like the square root or the fourth root of things, we have to introduce the fact that it could have been positive or negative, because when you fourth it right there, it doesn't care that the input was negative or positive. So both these inputs are going to work. Reminder, both of these inputs are going to work. You have to introduce plus or minus when you take a square root or a fourth root or a sixth root. Okay, all the even stuff matters. And the last one, we're just going to square both sides. And again, you squared both sides, so you do have to check the fact that both answers work. And in this case, the 4 works and the -6 does not work. So we cross it out and label it extraneous. Okay. The review number 2 is a little shorter, but it has everything on there: solving equations, graphing cube roots and square roots, talking about the domain of those, and then simplifying all of these guys certainly are all on the test.